Yesterday we went over that array fun program, and I wanted to mention something. I don't mind telling you this, and that is when you go into your constructor, make sure that the only thing that you do in the constructor itself in that for loop is to fill up those three arrays. Do not, I had all this stuff in the constructor. That was wrong. That was real wrong, okay? So the only thing you should be doing in the constructor is filling up the three arrays. Then you should take your min, max, sum, and average and initialize those. Then you can call your set, number ascending, etc. All right, and if you do that, this is what I got at least. So there's the original array. There it is in ascending order. There it is in descending order. There is the minimum, there is the maximum, there is the sum, and there is the average. All right? So that said, remember what we're going to do now today is I'm going to go over the material that we had for Chapter 9, and you will not be tested directly on anything from Chapter 9. But there's some points in there that are, I think, at least important enough to go through. And then after we get done with that, we're going to go over that Palindrome program that I told you about. That should probably get us to around 2 to 2:30, and then the rest of the period will be a lab period. And then tomorrow, I've written your pre-test, not your test, but your pre-test that I'm going to give you tomorrow. And I want to make, I won't give it to you until I do a key to make sure that it appears it's something you can do. All right, so I'll give you that tomorrow. You'll have about a couple hours or so to work on it, 2.5, whatever it is, and then we'll go over it as a class. All right, and then Monday of next week will be your next hands-on test for chapters 6, 7, and 8. All right. So, chapter 9, text processing and more about wrapper classes. We have talked about wrapper classes. You know what? You've used wrapper classes. You've used them a lot. And what do I mean? Well, you all know that you have done integer.parseInt, all right, double.parseDouble, etc. Those are wrapper classes. Those are examples of wrapper classes. Talk a little bit about character testing and conversion, I should say, with a character class. Some more string methods. We haven't talked about many string methods. All right. We'll talk about the Stringbuilder class. The string class that we've talked about is known as being immutable. All right. The Stringbuilder class is mutable. We'll talk about what that means when we get to it. All right. We'll talk about tokenizing strings. The wrapper classes for the numeric types, again, we've talked about that already. So, how many times have you heard me say that Java has 8 primitive data types? Probably too many times. All right. And as it says, they're called primitive because they are not created from classes. If you want to be able to treat a local primitive variable as though it was a class, you can use wrapper classes to do that. Normally, you don't have to do that, but it's something that the language makes available to you if indeed you want to, need to, have to do that. Now, I want everybody, if you'd all look up on the screen here, it says here these wrapper classes are part of java.lang. All right? The reason that java.lang is important is that's where a lot of stuff in Java is put. All right? It's the Java language class. All right? And that automatically gets included in your program, whether you include it or not. It's something that the system just makes available to you. All right. So as it says here, what wrapper classes do is they allow you to create objects that represent a primitive. That almost sounds like a misnomer, but that's what they mean. They allow you to go and do the equivalent of being able to do class operations on simple variables. They're immutable, like strings are. To get the value, you must call a method, and wrapper classes provide static methods that are very useful. I think they talk about in here, again, another one of these topics that's just kind of weird. It sounds weird, and you've got to really look it up to understand it because there's tons of really good resources online, but that is the idea of boxing and unboxing. So we'll get to that in just a bit. Here are the classes. Some of these we've looked at already. These are character classes. You know how to do a to uppercase, and if you look up here, there's an is uppercase. Well, if you wanted to check to make sure something was uppercase. Anytime that you see anything that starts with is like this, they're Boolean. They're Boolean methods. All right? You should know that by now. I don't think that's I don't think that's any kind of a surprise here to anyone. We know the two lowercase and the two uppercase, so a lot of this stuff we've looked through already, all right? Now, you may not think about it, but it is totally conceivable that you may have to do operations on string variables in Java, all right? Things like, as they mention here, figuring out what a substring is. And you can see they have, I'm not going to run through these, but they've got some examples. If you want to know more about these, you've seen me do this before, you go out to java.sun.com. When you're out there, you find Java APIs. Grab whatever one you want, probably the latest and greatest. And you might have to look through here because they keep changing this all the time. But somewhere in here, you can find out about all the string methods. If that's too much work, just Google Java string methods. And the first thing that it should come back with, or one of the first, is right there. All right, from the Help Center. So that gives you everything. And in here, this is pretty long. I'm not going to, go through any of it, but when you look in here, here's all the different things that you can work with strings. It's one of the bigger classes because, for instance, if you want to, starts with, well, if you want to know if something starts with something, it's pretty obvious what starts with will do, but what may or may not be obvious is how you use it. All right? So, the starts with determines whether a string starts with a certain string. The ends with, if it ends with something. The string class, as it says, provides methods that will specify regions to see if two strings match. That's kind of important because that region can be a whole document. So you might want to look through part of a document to see if something is in it. All right. Hopefully you've looked at this. We have actually looked at this with certain things. The ignore uppercase, or ignore case, I should say, which means that I don't care if it's uppercase or lowercase. All right. If I'm looking for a name, I don't care if it's Amin with a big A or Amin with a little a. It doesn't matter. And there's this same kinds of things that we went through in JavaScript. Index of, which finds the first location of something you're looking for. Last index of, which finds the last index. So this is kind of a weird example they give, but they've got the string 407 years ago, and they do the index of, and they find the first position. Well, that's going to be that one. And then they find the last position, and that's going to be that one. I believe it does start with 0. Why, this is kind of a contrived example because why you'd want to do that is way beyond me. This table has a listing of all of the basic string methods that you might want to use. All right. Notice with many of them, if you're looking for something and that something does not exist, it'll return -1. And especially in Java, that's a language where if you're expecting something, a numeric value, and it doesn't exist, normally -1 is what's going to be returned. All right. So there's 2 or 3 pages worth of these. Again, we're going to look at a couple of them when we go through the program in just a bit. There's different ways you can extract substrings. As it says, the substring method returns a string beginning at a start position and ending at an ending position. Okay? There are a lot of ways that you can do the same thing in here. So they're showing some ways, not the only ways. All right? You can use concat. Concat is just like using the plus sign. All right, so what does that give you? Not much that I can think of. You can do replace, which is very much like doing a replace in a word processing program. All right. So, for instance, maybe you wanted every instance of Missouri changed to MO. All right, so you'd be able to do that with a replace. Trim. Java does have a full trim method. We've looked at that in an earlier class, where it trims leading spaces and it trims trailing spaces. All right. Notice here the value of method. It says the string class provides several overloaded value of methods. They return a string representation of a primitive or a data type. It may not sound big, but if you look right there, what that does is it turns, for example, a Boolean into a string, or a double into a string, or a character into a string. So sometimes you want to do that. We've overridden the toString method, but toString in Java doesn't work like toString, for example, in C#. All right? But if you want to force something into going into a string, this is a way that you can do it. And they give you some examples, but it's pretty much what I just showed you. Now, this is new. And I've said this to you before. I know sometimes I end up hearing the same thing over and over again. But again, if I say string fname equals Jeff, then you've seen this before. Somewhere in memory, I don't care where, but somewhere in memory, the zeros and ones that represent Jeff are going to be put in there. So let's just say it's right at location 100. Then later on in my program, I say fname equals Jeffrey instead of Jeff. The system never, ever goes in and just adds REY here. It doesn't do that. Even if there's room, it doesn't do that. It finds an available spot in memory, and it puts, so maybe this is at location, I don't know, 963. JEFFREY. It does that, then it takes that address where that begins, and it says no one's using that. So it marks that. Then when the garbage collector that we talked about yesterday comes around, it says nobody's using that, so it flags it. It's like I told you yesterday when you put the little chalk underneath the tire. Then when it comes around again, if no one has still referenced it, then it gets rid of this. All right? But the idea with something being immutable is you can't just sit there and change the value of something and have it be in the same spot in memory. All right? And you might say, well, do I really have to care? All right? Well, the one thing about it is programs will run slower for that reason. All right? So, as it says, the Stringbuilder class is similar to the string class, but you can change it. So the string class is mutable. The Stringbuilder class is mutable where the string class is immutable. All right? So the Stringbuilder object will grow or shrink in size as needed. All right? There's different ways that you can set it up. Notice that if you just say Stringbuilder, it gives you enough string for 16 characters. If you give it a length, so if I said Stringbuilder and I put inside of here 100, it would give me the room for 100 characters. And I can initialize it with a string. It's sort of the equivalent of what we talked about with array lists. It's very similar to an array list in that it can grow and shrink. In other words, it's late binded, meaning that it's done at runtime. That's why it can grow and shrink. It has a lot of built-in methods, many of which are the same as the string class, some of which are different than what's allowed or what you can have in the string class. Notice the string builder class, unlike string, has several overloaded methods of append. All right, so you're able to append in different ways. You're going to see this in just a bit. Okay. So notice what they're doing right here. They're appending onto a thing called str 4 different values. The string we sold, the number 12, the string donuts for $, and the numeric value 15.95. Once you do that, you get we sold 12 donuts for $15.95. They're all strings. Even though the ones that got put in there in the second line and the fourth line were numeric, they're now strings. All right. It has both append, which means put it on the end, and it has insert. The thing with insert means that you can put it anywhere in the string. Append implies that you're putting it at the end of the string. Insert implies that you are going to tell it where in the string you want it to go. For instance, if I did something like you see up here, and let's say I had a last name or an L name equals Scott, and I put those into a string builder. Now I've got Jeffrey Scott. Now somebody later tells me that they want the P, my middle initial, in between there. I wouldn't use append because it would say Jeffrey Scott P. All right, so I would use an insert so I could tell it to put it between the two. All right. And again, you're going to see this in just a couple minutes. Okay. All right. It's got replace. It's got a lot of different things that we've already seen. Okay. Some of the examples that are in here are really contrived, but here are some more examples. Notice it says it provides methods to set and delete characters in an object. All right. So you do have some control with it. Now it says you can call the string builder's toString method to convert a string builder object to a regular string. So you can take a string and you can copy it to a string builder. You can do whatever you want to do with it, and then you can convert it back into a string again. All right. So there may be a reason that you want to do that. Again, you're going to see some of that in just a couple minutes. All right. Tokenizing we've talked about before. Okay, if you look at, if you've got a book handy and you look at a book, what is it? That book is tokenized into pages. The pages are tokenized into chapters. The chapters are tokenized, or I should say that chapters would be tokenized into pages. The pages into paragraphs. The paragraphs into words. The words into sentences, etc. All right. So the string class has what's called a split method. Notice what it does. It takes a string and it returns an array of string objects. So if I had a string that had my first name, my middle name, and my last name in it, and I wanted to break it up into 3 different variables, I could use the string tokenizer to do that. There's other ways you can do it as well. All right. So again, if you look up here, you'll notice there are 6 wrapper classes. They're for all of the numeric variables. What you should notice then is what's missing: char and Boolean. There are no wrapper classes for char and Boolean because a character is a character is a character, and a Boolean can only be true and false. All right? But as it says, it says Java provides them for all of them. Well, it's for all the numeric ones. All right. So how do you do that? This looks kind of weird. Notice when you use, if you look up on the screen here, you use the whole word integer and it's a capital I. All right. So it says new integer 7. Well, it's like, why would I ever want to do that? Well, the reason that you want to do that is there are certain methods that integer wrapper class has that you can use on a wrapped variable that you cannot use on an unwrapped variable. All right. We've done parsing, haven't we? I believe so. So they give an example in here, known as the parse methods. Here's a bunch of them. In fact, I think we've done most of these. In one of the first programs, we did like a byte.parse byte, an integer.parse int, and I think we did a double.parse double. All right. And what is that doing? That's attempting to take something that is not a number, usually it's a string with digits in it, and convert it into an actual number. All right. Each of the numeric wrapper classes has its own static two-string methods in it, or method in it that converts a number to a string. Okay? Again, this is number to string. Not only that, you can work with binary, which is base 2, hexadecimal, which is base 16, and octal, which is base 8. All right, we don't do any of that stuff, but you can. And there's not much more left in this chapter. All right. If you've never worked with this before, integer.min value is the smallest integer that your machine will hold. Typically, for an integer, it's negative 4 billion, 100 some million, etc. And max value is the biggest positive value that it'll hold. Typically 4 billion, 100 million something. All right? And this, yep, they do talk a little bit about auto-boxing and unboxing. All right? And it says here, you can declare a wrapper class variable, then assign it a value. So you can say integer number equals 7. All right? It says you may think this is an error, but number is a wrapper class because it's the integer with a big I. And since it is, as it says there, auto-boxing occurs. So it's as though, they call it boxing because it's as though it puts it in a special box so you can do things with it. When you go in the other direction and you take something that was a wrapper class variable and you make it a simple variable, that's called unboxing. And notice what it says here. You really need to do any of this stuff. But if you never needed to do it, why would they make it? All right. And that's actually it for the chapter. So let's do this. If you would, start up, if you don't have it running, please start up IntelliJ IDEA. If you still have your array fun program done, close that so we get to here. All right. I'm going to go and make sure that in my payrolls folder where I'm sticking everything, that I've got something in there that's, I want to create an empty directory that I'm going to call Palindrome. This is not a particularly long program. It's probably, I don't know, 70 lines or so. So I'm going to create a new project. You know the drill. Next, next. Give it the path. So it's going to be called Palindrome. So now I've got this. I'm going to come up into here, right mouse click on source, new Java class, edu.rankin.jpscott.palindrome. Mentioned this yesterday, but if you weren't here and if you don't know it, a palindrome is just something that's the same. It's a word or a phrase or a something that's the same forward and backward. All right. So I've got mine with a lot of comments in it, but I'm just not gonna put in a ton of comments. Okay, I'd like us to finish this. Again, if we get done with this, it's gonna be earlier than I thought, but let's say that it's 2 o'clock at the latest, it might be before that, then the rest of the period will be time for you to get this done and to get the Array Fun program done. All right? And it'll give me time to go and try to write the key for the test the pre-test I want to give you tomorrow. All right. So I'm going to do my PSV here because I want main. Everything is going to be in main. I don't care. I'm not worried about classes right now or anything. The idea behind this program is to show you a few things. We're actually going to use a string builder in here. All right. So at least you've got some initial exposure to some of the stuff that's in here. And that's literally, that is all that I'm trying to do. All right, so the first thing I'm going to do, as we usually do, is we're not going to have any constants in here. So I'm going to declare and initialize the program variables. All right, and I have 1, 2, 3, 4, 5, 6, 8 of them. Most of which, but not all, are strings. All right, so make sure you put this in. These are what? About 8 different variables that we have in here. I might have said 7 before, but make sure you add these. All right. Now, again, if you weren't here yesterday or weren't listening when I went over it, this is what we're going to do. We're going to allow you to put in a string of data. So let's say I put in my name, but I put in J, E, because I can mix case if I want to, asterisk, exclamation point, 37, comma, and then let's say that I want to put Jeep, or well, that's a stupid one. I'll put Peep in here. How's that? So PE. Then I come back with a little e. I put another comma in, a whole bunch of garbage. 777P. All right. What we want to do is originally to start with, we want to strip out everything in here that's not a letter. So when we get done, we'll have P, E, E, P. All right. Then we want to take what's left and either uppercase it or lowercase it. All right. So we'll uppercase it. Then we want to take what we have and read it backwards and make sure. So we're going to have, that's what that rev string is. It's whatever we have reversed. And then we want to check and see if they're the same thing. Does that make sense? All right. And we need the string builder because as we're ripping stuff out of here, okay, this is a string that we're using the input, but then we want to be able to build this piecemeal by going through this. All right. That's why we're using the string builder. You'll notice if you look on here, the last variable says string builder. So that is not of type string, that is of type string builder. Okay? Now you know this, don't do this, but you know this line right here, literally with this line right here, and again, don't do this. This line literally means do this. And if you didn't know it, that's what it means. That's what it tells the system to do. It's just that they have a shortcut built into the Java language package that if you do it the other way, it basically converts it to this. All right. The reason I'm telling you that is, to my knowledge, there isn't one like that here. So you can't say, I believe if we come in here and try to say, double quote, we get an error because we're trying to take a string value and assign it to a string builder object. Does that make sense? All right. So in other words, we're breaking the rules. Okay? And the system is not going to let us break the rules. All right? We're going to take this whole thing and put it inside of a while loop, and run flag means we want to run the program. Okay? So we're going to start here by saying while run flag. Okay? So everything that we do is going to be inside, I think virtually everything that we do is going to be inside of this while loop. Double check, but I believe so. Yeah, we'll find out as we go along. All right. Now, what we want to do is when the user runs the program, we want it to come up and give them a message that says something along the lines of, please enter a string, and I'll tell you whether or not that string is a palindrome. In other words, the same forwards and backwards. Okay? So that's what output string is going to say. I'm going to get the error right now because I'm using J option pane, but we'll fix that in just a minute. I think we need null there. All right, so there's that error. And if I take my mouse, click on there, do an Alt Enter, it'll say, do you want to import the class? I do. That fixed it. Okay? Now, don't type in this, but I'm just going to put a line here that says run flag equal false. Don't put that in. I'm going to get rid of it in a second. Do not put in this line, please. All right? But all I'm trying to show you here is if I do a file save all and I run the program, that's what we get. All right, and again, that should make sense to you. And I've been really trying to tell the first year people that, you know, I say this and sometimes people laugh. I don't think it's funny, but there is no accounting for human stupidity. In other words, I'm trying to tell you what to do here. But if you refuse to do what I'm telling you to do, all right, I mean, what can I do? I'm telling you to enter a string. If you just enter a bunch of numbers and letters, etc., it's not going to be a palindrome, right? Because I'm going to take out everything that's not alphabetic. All right. So I'm just going to click OK. That's fine. All right. So I'm going to get rid of that run flag equal false. So am I right in assuming everybody understands what that means? All right. We're just building something to stick into a J option pane. All right, I am going to put a couple comments in here because I want you to hopefully understand what's going on. All right, so I'm going to put a comment here. Again, people always ask, do I have to put it in? put it in if you want to, and don't put it in if you don't want to. All right? So I just showed you up here what's going to happen. But again, I'm putting a comment in here as well. So if you've got somebody who's much more uninformed than you, they can at least look at the comment and ideally have... What's that? Oh yeah, you're right. Yeah. Let's see. Remove all the letters from it. Okay. How about if I put this? Capitalize the letters in each string. Okay? Sorry about that. Thank you. I did not have that in my comment. And again, one of the reasons for showing you this one is we are going to use some of the stuff that you just saw in the actual chapter. All right, for instance, you may or may not remember, but when I showed you one of those first charts, there was a thing there called isLetter that checks to see whether what you're checking on is a letter or it's not a letter. Well, we want to use isLetter as we're working our way through here, and if it returns true, we want to copy it from our original string to our string builder. And if it's not, we just want to skip it. All right? Okay, this is going to go through every line, every character in the string, character by character, all right? So what do I want to do? I want to say if character dot is letter, all right, and I want to make sure it's the current character. Okay, we'll go over all this in just a second. What doesn't it like here? Cannot resolve method append. That's not good. Oh, it's a little a. I'm sorry. That's better. All right. So again, I'll leave that up there. It's not going anywhere. But if you take a look, what this is saying is go through your string, character by character. So the original string, again, is something like this. So go through it character by character. And if what you check for the current character is a character, meaning it's a letter, it's an alphabetic letter, then add it or append it to our string builder string. All right? So that's what I just showed you up here. That's exactly what we're doing. Now there's no else in here, because if it's not, we just want to skip it. So there's no else. And that's actually it. That's actually it for the for the for loop. We're not doing anything else in the for loop. All right? So little t. Hopefully you can take a look at the comments and kind of figure out what's happening based on the comments that are there. Now, just so you know, I mean, did we have to do it like this? This is probably the easiest way to do it, all right? What we could have done is when we had this, let's assume when we get done that the string we have looks something like this. I'm just making this up. M, A, J, B, K, L. Well, you know, looking at that, there's no way that that is going to be a palindrome. You know that, all right? But when we reverse it, we get L, K, B, J, A, M. And then we just compare those two. Okay? So then we'll compare those two strings. If we didn't want to have a reverse string, we could copy this string. We could copy this string to another string. All right, so it looked just like that. Then if we wanted to, rather than having a reverse string, we could say, put this in a loop and go from here to here. Put this in a loop, but go backwards. So there's a lot of ways this program could be done. Just trying to come up with a way that I consider to be the most intuitive. All right, you may or may not agree with that. So, we did that up. Oh, you're right. What I should have done, yes, you're right. The question was, do we need to make the reversed uppercase also? When I was working with it, I actually had some problems when I made it. When I was doing some stuff with uppercase, it would work and then it wouldn't work. So it gave me a chance to try something else, which I did, and you're going to see it in just a second. So to answer your question, if you hold on for a second, I think it'll answer your question. All right. All right. Now that I have two strings, I don't have to put them in a loop. I don't really have to even do anything. I can just do the string compare operator. All right. And I'm telling it to ignore the case. All right. That literally is it for the program, except we want to be able to run it again. All right. So you've seen this kind of thing before. I'll give you a second to type that in. If we ran it now, it would work fine, except it would be in an infinite loop because we haven't asked the user if they want to run the program again. So we're going to do that in just a second. Let's see, we probably have about a dozen more lines to key in and then we're finished. So I'd like to keep going rather than going on a break. Let's just finish this and get it done. So again, this is comparing the two strings, the beginning one and the reversed one, and ignoring the case. So technically, because the question got asked about doing the two uppercase on the other one, you really wouldn't even need that. All right? Because you're comparing the two and you're ignoring the case. All right. Yes, I did. But actually, it was way over here, so, but you are correct. So again, this is saying if you put in anything other than a Y for the first character in the program. All right, I'm not even putting comments there. I think hopefully at least it's pretty self-evident as far as what's going on there. All right. I believe that's it. I'll come right back. Just give me a second here. Oh boy, isn't that nice? What do we have here? I spelled it Palindrome. That's really nice. Yours really should be Palindrome, but it doesn't really matter. But this particular example allowed us to use the is letter. It allowed us to use the string builder. It allowed us to use the char at, which we had already used before, and the two uppercase. I thought, out of all the ones that I looked at, this one probably did the best out of showing some of the stuff that was in Chapter 9. Now, I'm going to try it to make sure I didn't make any mistakes, so I'm going to do a save all and then build it. Run it, I guess. Oops, I don't know what happened there. Run. All right, so there it is. I'm going to try putting in the same thing as here. P, E, asterisk, exclamation point, 37, comma, little e, comma, 777 in a capital P, and it says it is a palindrome. All right. Why? Because it, again, pulled out everything and then compared the two strings. Do I want to run it again? Sure. Yes. Well, Jeff is not a palindrome. Okay. So it appears at least as though it works. So again, this is the only specific time in here that that you are going to have to worry about the is this and is that kind of an idea. All right. You may on your next program, I don't know. We've already done this where you want to run it again, but I don't even think we're going to do that. All right. Now again, yesterday I sent you all an email, and remember there's 4 things you're supposed to do with that array-only program. Number 1, you are to try to use the Java sort method to sort your stuff in ascending order. That's number 1. All right. Number 2, you are to for the reverse, since there is no built-in reverse, I sent you a URL that showed you how you can do that using an array list. All right, so you are to try that. Just one sec. Number 3, you are to try putting in a binary search. The question got asked yesterday, well, how do I do that? Do we ask the user, etc.? Yeah, that's probably a better idea. And number 4, you were supposed to change all of the system.out.print lines to J option pings. Yes?
I was having trouble with the reverse. I'm wondering if you could either help me or
Yes, once we finish with this. Right. Has everybody gotten a chance to key everything in? All right. Like I said, it's not a very long program. It's about 90 lines, but it's 90 lines because I put blank lines and I put comments in there. I'm sure at least 10% of this, probably 20% of this program is comments. So we're talking about probably about 60 or 70 lines. So, again, just one more time so you've got an idea of what's going on here. Tomorrow, pre-test. All right? Whatever time is left after that, you'll have to work on this stuff. On Monday, you will take your next test, and that will be on chapters 6, 7, and 8. Starting on Tuesday, then, for the rest of the week, we're going to cover 2 more chapters, 10 and 11. Chapter 10 is on inheritance. So for that payroll class, we're going to make different kinds of people who work there. We will have a commission worker and a piece worker and an hourly worker, etc. We'll do that, and then in chapter 11, we'll learn how to write our own exceptions. Okay? Then what I'm actually thinking of doing is going over chapter 12 almost right away, because that's we'll rebuild the program as a GUI program. All right, and that might almost be it for the Java. All right, so we may be by the end of January almost, we may be done with the Java part of the class. All right, then we can go right into Android, and that's good because that gives us February, March, April, and half of May to just do Android development. I think that's good. Again, any questions on this? All right. So the rest of the period is yours. If you want to take a break now or whatever, that's fine. And I'll be over by you, Colin, in just a couple minutes. Okay.